Hi, everyone. Welcome to the August webinar for Azure Database for MySQL. I'm Saurabh Kirtani, a Senior Product Manager with the Microsoft Azure team. Today, we have an interesting list of topics that we'll be covering with speakers across product and engineering from the Azure Database for MySQL team. Let's go over the agenda quickly. First up, we'll have Elendil joining us to share about one-click self-heal, extended support, and key maintenance experience enhancements. Then we'll hand it over to Ram, who's going to be talking about the MCP server that we've just introduced for Azure Database for MySQL. And next, I'll come back to share a recap of the latest feature releases and updates across the past couple of months. With that, I'll hand it over to Elendil to talk about boosting reliability and lifecycle management.
Thank you, Saurabh. Let me start sharing my screen. Okay, can you see my screen now? Okay,
Yeah.
Cool. So, hi everyone. My name is Elendil. So I am the Senior Product Manager in Azure Database for MySQL. Today, I'm going to tell you that how to boosting reliability and the lifecycle management in Azure MySQL database. Okay, let's go to the next page. My agenda will cover 3 different topics: maintenance experience improvement, self-help of Azure Database for MySQL, and the most important thing that a lot of our customers are interested in is the Azure Database for MySQL extended support. Let's first go to the maintenance experience improvement. So we recently announced a lot of new features for our Azure MySQL maintenance experience. These improvements are virtual canary GA, which will allow our customers to early validate our new features in non-production environment. Second is the stage custom maintenance window. It will allow our customers to stage your updates across different environments. And then the maintenance rollout progress view, it is currently in public preview. It provides fleet-wide visibility during maintenance. It is very useful for customers who manage like hundreds of Azure MySQL database instances when they have maintenance. Let's start by watching the video.
Let's start by looking at how you can configure and monitor maintenance behavior in Azure Database for MySQL. In Azure Portal, navigate to your MySQL Server resource, then go to the Maintenance blade in the left menu. This is where you can configure your server's maintenance preference and view upcoming or past maintenance events. The first feature I want to show you is Virtual Canary. Virtual Canary is designed for non-production workloads that want to validate updates earlier. Servers under this policy receive updates ahead of general availability. Unlike standard maintenance case, Virtual Canary servers do not follow a fixed 30 days update interval, do not receive 7 days advance notifications, and are updated earlier than production servers. Burstable school servers are enrolled in Virtual Canary by default. If you want to opt out, you can switch to a system management maintenance window. For servers in the general purpose or business critical compute tiers, you can opt out Virtual Canary by selecting either a system management maintenance window or a customer management maintenance window. All of these options are configured directly in the maintenance blade. Next, let's look at the maintenance batches, a feature that gives you more control over how updates are rolled out across your environments. You can assign your server to either batch 1 or batch 2, which is especially useful if you want to stage your maintenance between environments. For example, test in batch 1 and production in batch 2. Please note that maintenance batches are only available when you've selected a custom maintenance window. If you are using a system management maintenance window, batch assignment is not applicable. You can also choose to have no preference, in which case your server will be scheduled based on general rollout logic. Now, let's move on to the maintenance rollout status check, which is currently in public preview, and I'll show you a live example. When a maintenance event is scheduled, you'll see a tracking ID in the maintenance blade under the maintenance status grid. Clicking this ID opens a detailed view showing all servers in your subscription that are part of the same maintenance rollout. This gives you a consolidated overview across your fleet. No need to check each service individually or rely solely on email notifications. Alternatively, you can also access this view by going to the Server House planned maintenance section. Let me show you this in action. I've already scheduled the maintenance for 2 servers, and we can now click the tracking ID to view their rollout status side by side. As you can see, the dashboard shows the current state of each server, their batch and their current their regions and their server name. You can click the More Info link to see the maintenance status, or you can export the overall status by click the Export to CSV button. These features, virtual canary, maintenance batches, and route status check, are designed to give you more predictably control and visibility during maintenance operations. They help reduce risk, improve planning, and ensure your environment stay stable and well managed.
Okay, so next I'm going to show you another demo of the SelfHelp capabilities. SelfHelp is a innovation to our Azure database for MySQL. So it can include, it now includes 2 different SelfHelp mode, which is non-impactful SelfHelp and impactful SelfHelp. SelfHelp supports different scenarios that in its initial release, it supports a focus set of scenarios, including missing or corrupted logs, server unresponsive or unreachable, server availability issues, for example, stuck in restarting state, or server stuck in management operations, for example, changing server parameters. Let's take a look at the server SelfHelp demo.
Let's start by looking at how you can configure and monitor maintenance behavior in Azure Database for MySQL. Let's start by looking at how you can access the SelfHelp feature in Azure Database for MySQL. In the Azure portal, navigate to your MySQL Server resource, then go to Help, and go to the SelfHelp section in the left menu. Here, you'll find the SelfHelp option. This is where you can manually trigger a recovery option when your server encounters issues. Once you open the SelfHelp blade, you'll see 2 recovery modes available, non-impactful and impactful. Non-impactful SelfHelp mode. This mode is designed to fix the light-weighted issues without causing server downtime. It's ideal for problems like failed server parameter updates, missing or corrupted logs. It's safe to run and typically completes very quickly, keeping your server online throughout the process. Impactful fix. This mode may involve server downtime, but it's necessary for more serious problems, such as server stuck in a restart loop, connectivity or availability issues caused by transient infrastructure problems. Impactful SelfHelp performs deeper recovery actions to bring the server back to a healthy state. We recommend starting with non-impactful SelfHelp, and if the issue persists, then proceed with the impactful SelfHelp. One important note, do not leave the self-help page while the process is running. If you navigate away, you won't be able to track whether the operation has completed, and you may miss the recovery result. So please stay on the page until the self-help process finishes. After the self-help completes, wait a few minutes and then retry the operation that previously failed. For example, if you had trouble connecting to the server or applying a server parameter change, try again after the recovery. Some recovery actions involves internal stabilization or log reply, so give the system a short window before verifying. This applies to both non-impactful and impactful modes. You'll need to manually confirm whether the issue has been resolved. SelfHelp is a powerful recovery tool built into Azure Database for MySQL. It gives you flexibility to recover from both minor and major issues with minimal effort and no need to open a support ticket. Whether you are dealing with a stock server or a failed configuration, SelfHelp helps you get back on track quickly.
Okay, now let's go to the extended support. A lot of our customers actually reached out to us in terms of how Microsoft are going to deal with the end of life Azure MySQL versions. So based on our customer feedback, we'd like to introduce the Azure Database for MySQL extended support. It's support for legacy workloads beyond open source end of life. So what included in the extended support is that we will still providing security patching for MySQL 5.7 and 8. And in the future, if there is a new end of life MySQL versions, we're also going to provide a security patching for those versions. Also, we are going to provide SLA backed support, and we will provide a customer with the upgrade flexibility. So this is the timeline for our Azure Database for MySQL extended support. We are going to publish our pricing details in Q3 this calendar years, and our standard support for MySQL 5.7 will end at March 31st next year. And then we will start providing the extended support for Azure Database for MySQL 5.7 in April 1st to 2026. As you also know that MySQL 8 are going to end of life in next year. So we're also going to start provide the extended support for MySQL 8. So we will end the standard support of MySQL 8 in May 31st, 2026. And in June the 1st, 2026, we will start providing the Azure extended support for MySQL 8. So both of these two extended support will last 3 years. So we will provide enough time for our customers to upgrade their database to the latest version. So please note that this is a 3-year offer, and in the last year and the third year, the pricing will be a little bit different. Any details, please wait for our extended support costing details in our pricing calculator in Q3 this year. So thank you, everyone. Back to you, Saurabh.
All right. Thank you, Elendil.
Yeah, thank you.
Next up, we have Ram, who's going to join us to speak about the MCP server that we've just introduced for Azure Database for MySQL. Over to you, Ram.
Thanks, Saurabh, for introducing me. My name is Ram. I'm a software engineer here in the MySQL team. And today I want to talk about MCP Server for Azure Database for MySQL. So what exactly is MCP Server? It was a very recently introduced open standard by Anthropic that enables any AI systems like LLMs, right, to interface with external tools and data sources through a unified protocol. So this is a way in which you define how LLMs talk to data sources, right? So it will be like a USB-C for AI in which you can plug into any sort of LLM and it will know how to talk to the data source, right? In this way, multiple AI agents will be able to talk to a single data source through a unified protocol. That is the whole goal behind having this model context protocol. And today, we'll see how we can expose capabilities of the Azure database for MySQL, right? Obviously, if you have data in MySQL database and you want to interact with that data through an AI agent, right? We are defining MCP protocol as a middleman to say multiple AI agents can plug in and query the data present in the MySQL database. We have several capabilities like listing tables, normal SQL queries, modifying data, fetching server metadata. All of these capabilities we'll expose through an MCP server. I have a detailed blog post detailing on how to set up this using Python, an MCP server for Azure Database for MySQL, and this is the link. So today we'll look at a demo of how we can do that. Yeah, so here in this diagram, you see on the left side is the MCP client, which is an AI agent. It can be Cloud Desktop, GitHub Copilot, any AI agent or application of your choice. On the right-hand side, you have the data source, which is the MySQL server. And as a middleman, we are going to be hosting the MCP server in Python, right? Which exposes the capabilities of the MySQL server to the AI agent on the left-hand side. So this is the overall architecture for having the MCP server. MCP client and server sort of reside in the same machine. So here I'm going to provide an example using Cloud Desktop on how to add an MCP server using the file settings and config. So it's a simple JSON file which defines the MCP server as to what command to run and what are the arguments and the environment variables for that process. So here we'll be using Python and the MCP Python script that I provided in the blog post. And to it, you will pass some environment variables like the host name, username, whether to use the AD, the subscription ID, and the resource group. So the Python scripts uses these variables to connect to the MySQL server. And yeah, this is the script I have put in GitHub as well. The link is there in the blog post as well. So you can download the script and host it. So once you have all of this and you have configured Claude to host this MCP server, you can click on the tools and see that it has been updated to have all the new capabilities that this Python script exposes, right? All the capabilities to interact with the MySQL database. You can enable and disable based on whatever tool you want. And then now we'll add some context to say like one of my databases, I'll add that as a context and then start asking questions about this one. I have prepared 4 questions here. So we'll be going through one by one. So first 2 are like querying the properties of the database itself, right? What is the version of MySQL in the MCP server, right? And then here you can see the AI agent is constructing a SQL query, select version as MySQL, and executing it through the MCP server, right? And it gets back the version as 8041 from the result. So in this way, LLMs are able to interact with the data in the MySQL database. This is a very simple query to get the properties or the version of the MySQL. Let's look at some more examples. Okay, click on the pause button there, Saurabh. Yeah, click it again. Yeah, the next question will have like, what is the maximum number of connections that I can use, right? So this is an example of querying the server configuration parameters, right? MySQL Server has different parameters, right? And one of the parameters is max connections. And so we'll use this capability called get server parameter that will go and extract the value of the parameters and say, yeah, your MySQL Server can handle 171 connections, which is the value of the max connections parameter. And to query some data, I've loaded the iris data set, which is a flower data set in this database. I'm going to ask some questions regarding the iris data set to say plot a histogram of the distribution of the petal length, right? And I did not tell it like where is this table, where is the database. And so you can see the AI agent getting the schemas, getting the database list, and finding out where this petal length exists. And once it finds it out, it queries the petal length from iris table and gets the data and plots the histogram, which gives you insights immediately into the frequency distribution, min, max, and all kinds of data. Let's ask it some more complex questions, like which iris species has the biggest share of extra long petal flowers, right? In this way, the LLM has to query multiple, it gives multiple SQL queries to understand the data, as you can see here, right? Several SQL queries, and then once it gets the required data, it'll give out the answer saying Iris virginica has the biggest share of extra long petal flowers by analyzing the data. So in this way, you can interact with the data in your MySQL database easily through natural language. You don't need extreme SQL knowledge to construct all of this, right? And so the capabilities are endless here with this MCP server, and it enables you to get intelligence easily out of your data in your MySQL database. That's all I have for the demo today.
All right, thank you, Ram. Very interesting. So for our viewers, feel free to try this out, the MCP server, and give us feedback. Uh, Next, we'll move on to the next topic, the last topic for the day, which is going to be a recap of the latest feature releases and updates. I'll be speaking for the next few minutes and share a brief overview of each of the updates that we have released over the past couple of months. And let's get started. So the first one is accelerated logs in general purpose service tier. So this is a feature ever since we've launched this in the business critical tier. We've received tremendous customer love over the past few months. Uh, for those who are not aware, this is a feature which is designed to boost server performance, improve throughput, and reduce transaction latency. And once this is enabled, the server can automatically store transactional logs on faster storage. With all the customer love that's been coming in, we are very excited to announce that this is now supported for general purpose service tier as well. So for all of you who are on this tier, you can go ahead and try this out. Next up, enhanced failover performance with high availability. So we are excited to announce that uh, a dedicated Azure standard load balancer for high availability enabled servers is now in public preview. And this enhancement improves failover performance and ensures more efficient handling of MySQL data traffic. It also enables low latency and high throughput distribution of front-end traffic across the backend servers. And right now, if you want to enable the SLB for your high availability enabled server, you can contact us. The link is right there on your screen, aka.ms/msazure/support. And we'll be happy to work with you to enable this for your HA enabled server. And this will hopefully lead to enhanced failover performance for you. Next up, we have some updates to the backup experience that we have launched over the past couple of months. The first up, it's automating the scheduling of on-demand backup. So now you can, using automation tasks, you can schedule the on-demand backups, providing you greater control and flexibility in terms of when you want to run that task and schedule the backup, rather than just relying on the system-generated backups that we, as Azure Database for MySQL team service, do today. And the next update that we have is you can now configure the interval that the backup interval for backups to provide you the capability to take those backups more frequently. So it used to be every 24 hours. We have given some more options in the portal today where you can go ahead and make that setting to enable it more frequently. And a good result of that is that since these snapshots or backups that are being taken are more frequent, they reduce the number of bin logs that need to be replayed for a point-in-time restore, thereby also helping you to minimize the overall restore time. So please go ahead and try this feature out. We're very excited to launch this and give us feedback. Next up, we have input and output bindings for Azure functions, which are now generally available. We have so just before I move on to the more details, I want to share about an overview of the feature first. So first up, input bindings, they allow your function, your Azure function, to retrieve data from the database, from the MySQL database, without writing any manual connection or SQL query logic behind the scenes. And output bindings, as the name suggests, it allow you to update or insert data. So input is simply you retrieving data from the database. Output is you're inserting or updating data in the database without writing explicit SQL commands. And this integration is particularly useful because it helps to create scalable and event-driven applications with much more clean and maintainable code, because you don't need to put in the manual connection or the SQL logic behind the scenes anymore. There's also some work that we are doing for trigger bindings for Azure functions. So hopefully in one of the previous webinars, we have talked a bit about that as well, where it went public preview. So that trigger bindings along with input and output bindings is a great integration that we've just brought to our customers. So please go ahead, try it out, and give us feedback of how you're using this. We have a bunch of more updates, which we won't go into too much detail at this point in time, but I'll just give a brief overview of each of them. So now we've launched new regions support for Azure Database for MySQL. So we are now available in Indonesia Central, Chile Central, and Malaysia West. And it expands our footprint of availability of Azure Database for MySQL across several regions. We'll be sharing a link to the full list of regions that are available now in the description in the video. We also launched custom port support, which is now in public preview. So please go ahead and try that out. We've released a bunch of more updates around auto initializing time zones and also helping you to enable the auto scale of IOPS. Specifically this one, which has been a good customer feedback coming to us. So very excited to launch this, enabling auto scale of IOPS. And all the releases, if you just go back and review, all of these releases help all the customers build those business critical applications, build enterprise scale applications. And we've seen some great feedback come to us over the past few months with these updates that we have been bringing up to you. So thank you for giving that feedback for the past few months, and thank you for being with us on this journey. We'd love to get your feedback. And all the updates that we're talking about, including what Elendil spoke about, including what Ram spoke about, including a recap of the updates that I've been speaking about, they are also available in our blog that we published a few days ago. The link to the blog is right here, aka.ms/mysql-july 2025-recap. And here it goes into much more details about each of these features. So if you want a ready reference for any features that we are speaking about or go deeper into the flows, feel free to go ahead and try it out. Also, please feel free to contact us directly. We'll share our email ID where you can get in touch with the product team directly. And if you have any feedback or questions or need some assistance with deploying it for your use case and scenario, please let us know. I'll just go over quickly the documentation and resources that we have. So here are a few links to help you, go and understand the resources and the documentation for MySQL. The last one here specifically is the email ID, ask Azure DB for MySQL at service.mysql.com, where feel free to contact us and we'll be happy to engage with you here. And thank you to all our viewers. across our streaming platforms. You can subscribe to our YouTube channel and follow us for staying updated on our announcements. Here are the links to the various social media channels that we have across YouTube, X, and LinkedIn. You can also message us directly for all the platforms that support it. On these platforms, if you have any questions or doubts or want to engage with us more, so these are also avenues where you could come in and contact us directly. And with all these platforms, you can subscribe just so that you learn when our next webinar is going to be scheduled as well. So, and if you want to appear in a live webinar in future or just collaborate with us, you can write to us at the same email ID. And for the webinar today, please fill out this form and provide your feedback. It will just take 2 minutes of your time, but it just helps us ensure that we bring you the relevant content. If you have any requests for the webinar going forward, let us know. With that, thank you all for tuning in today, and we hope to see you next time.